Welcome to the Grade 5 video for best practices on volume. As we explore here, we will discuss what one could see and hear as they visit math classrooms. So I have an ongoing joke with my students while teaching volume. I always feel the need to differentiate finding the volume of a rectangular prism and not the volume as in how soft or loud something is. During this unit, our focus will be on finding the volume of right rectangular prisms with whole number dimensions. Over the next two slides, you will see the key concepts being taught in this unit. These key concepts can also be found in the STEMscopes parent letter. I can reason that volume is the number of unit cubes needed to fill a solid figure without gaps or overlaps. I can use concrete objects to measure volume. I can use unit cubes with a length, width, and height of 1 unit to measure volume. I can select appropriate sized units for measuring volumes of varying size. I can determine the volume of a rectangular prism. I can use a visual model and a formula for finding the volume of a rectangular prism. I can solve real-world problems involving the volume of right rectangular prisms. I can write an equation with a variable for the unknown to represent a problem with volume. What should we see happening in the classroom to help students achieve these goals? Here we see 3 short segments from the STEMscopes Explore videos. Students should use concrete objects such as unit cubes to measure volume. In the first video, the number of unit cubes covering the bottom layer are built up by adding layers on top until the solid is filled. Students should reason that the volume is the number of cubes needed to fill a solid figure without gaps or overlaps. As students develop their understanding of volume, they recognize that volume is measured in cubic units and represented by an exponent 3. Through a lot of practice with visual models, students come to realize that the number of unit cubes needed to fill a right rectangular prism is equal to the product of its 3 edge lengths, length, width, and height, and also equals the product of the base times height. This is where the concept of volume extends from their understanding of area. Instruction then progresses from finding the volume of rectangular prisms to finding the volume of composite figures. They recognize volume as additive. As students describe and reason about why volume formulas work, they will apply these formulas to find unknown lengths. Students must understand that division is the inverse operation of multiplication, and the volume can be divided by the product of the known sides to find the unknown length. This lesson would highlight MTR 2, 4, and 7. The types of questions we ask the students will help facilitate the student conversation within the math classroom. Here are a few examples of math chat questions taken from STEMscopes. In the first question, students should reason that the number of unit cubes it takes to fill up the rectangular prism represents the volume of that 3-dimensional figure. Eventually, they can apply the formula for volume as they count the cubes to discover the lengths of the dimensions, length, width, and height. Looking at the next 2 questions, students will apply their understanding of area, length times width, to understand how the volume formula, base times height, is another way to solve. The base is the area because we multiply the length times the width to find the area of a rectangular prism. Out in the real world, students may ask to do a variety of things where they need to understand the volume. Some examples include packing for their lunch using plastic containers, packing a suitcase for a trip, packing a box with clothes they've outgrown to give away. You'll notice that these questions are typically open-ended and will stimulate conversations from the students. The conversation from these questions could demonstrate MTR 2, 4, and 7. As students participate in classroom discussions, it is important for both the teacher and student to engage using correct vocabulary words. Here is a list of some of the possible vocabulary terms we could hear during this unit. This list can be found on the STEMscopes parent letter as well. Throughout the unit of study, we see a number of opportunities for the students to demonstrate their understanding. This may include students' journals or exit tickets during the Explore, or the Show What You Know tasks as a follow-up. Students may also use the fluency builders with games to practice and elaborate on their content knowledge. These activities provide the teacher with informal assessment to gauge the student understanding throughout the unit. As we visit classrooms, we may want to ask students questions to measure their understanding of their current learning. Here we see 3 questions we could ask students as we visit classrooms. These questions will help us assess their understanding of finding the volume of right rectangular prisms. These questions come directly from the benchmark pages on SmathSmarts.com. This resource can be found by clicking on any of the benchmark links found in the instructional guides. We always want to encourage students to continue their learning at home. We want the tasks that we send home to be engaging and meaningful. The activities shared here are taken from the STEMscopes parent letter. On the first task, volume of a prism, our students will measure the dimensions, length, width, and height of real objects at home, for example, a cereal box, and then use the formula length times width times height to find the volume. In the next activity titled Roll the Volume, players will roll a die 3 times to represent the 3 dimensions. After each player multiplies their 3 numbers, the players with the highest volume earns a point. Whoever reaches 5 points first is declared the winner. Finally, you see the activity called Volume Math Libs. This may sound familiar to you, as Mad Libs have been around for years. As an extra challenge, if you look at number 3, you'll see that we can give the student a total volume and 2 of the missing side lengths. The students would then have to find the missing unknown side. Hopefully, the information and resources explained here in this video show the importance of teaching volume first using those concrete unit cubes and visual models, and then moving to students using the formulas volume equals length times width times height, and volume equals base times height. Thank you so much for joining me today. I'm looking forward to sharing more information in the next Best Practices video.